Hello, welcome. Today is going to be a very quick rundown of the two demonstrations that we did last class. This is for people who missed class. I know some of you were doing other things, some of you were out sick. And so this video is not going to include any discussion because it's just me by myself doing the demonstrations in a controlled environment here in the back of my classroom. So you can see that I've already got demonstration 1 running right now. It's over here, running on the computer, collecting temperature data. And it's going to be running for several minutes. And while demonstration 1 is running, I will quickly explain what it is. So what we have here is crushed ice being heated on a hot plate with a temperature probe. The temperature probe is recording the temperature of the ice as heat continues to be applied. The goal of this demonstration is to hopefully produce a live phase change graph of the ice as it melts from water into a liquid, and then as it goes from liquid to gas. Okay? So that is the purpose of demonstration 1. Demonstration 2 is actually a series of demonstrations that have to do with dry ice. Dry ice is the solid form of carbon dioxide. So in class I asked, how would you make dry ice? And I asked a bunch of other leading questions to try to get people to think about it, but there's no one here but me. So I will just be giving the answers to those more basic questions. The next thing that it wants you to do, the next question asks, what do you observe when the dry ice is exposed to the classroom air? You can see it here, the wisps of smoke coming off. So write down what you observe when the dry ice is exposed to the classroom air. And it can make it a little more obvious if I blow on it a little bit. All right? Okay? So write down your observations there. And I want you to think about, what is that smoke coming off of it? What is it made out of? What molecule is it? Why is it appearing? The next question asks, what do you think will happen when the dry ice is placed in water? So this is just regular water that I've added a little bit of soap to. That little bit of soap will make it a bit more apparent. So before I actually do it, make sure that you guys can actually see the beaker and the piece of dry ice. All right, before I actually do it, that's the lid and frost effect. One day I'll tell you guys about that. All right, before I actually put it in, I want you guys to pause the video, those of you who are catching up, and make a prediction of what do you think is going to happen when I drop the dry ice into the container of soapy water. Now I'm going to drop it in and we'll observe what happens for a few minutes. Let me get it close up. All right, so you observe what's happening. So now I just want to point some things out. Look what happens when I pop the bubbles. What is inside of these bubbles? What do you think is inside of these bubbles? How long will this continue to create these bubbles? When will it stop? So the next thing on demo 2, it asks you, what is sublimation? Well, you actually just observed sublimation a few minutes ago when I took the dry ice out of out of the container and exposed it to the classroom air. So I want you to think about what happened. What did you observe? Well, you observed that gas coming off of it. That's sublimation. Sublimation is when a substance goes directly from its solid state to its gas state. You observed that gas coming off, but there was no liquid state in between. So it was going straight from solid to gas, and that is sublimation. Next question is asking about placing dry ice in a sealed container. So I have a container, I haven't sealed it yet, but it's filled with dry ice, or about halfway filled with dry ice. What I'm going to do is I'm going to pour some hot water into it. Hot water is right here. And then I am going to seal the top with a balloon. And I want you to predict what you think will happen when I pour in this hot water, pour it in, and then seal it over the top with the balloon. I want you to predict what you think is going to happen. All right? So I'm actually going to get some hotter water. So while I get some hotter water, enjoy this close-up of the melting ice. So now I'm going to pour the hot water into the container and then seal it with this balloon. So I'm going to pan back a little bit so that you can see a little bit more of what's going on. Make sure that that's all within frame. Perfect. Let's do it. I got some extra. Let's see another. Okay. I don't think we're gonna get a third one out of this. Oh, turns out we totally are. I can respect how powerful this balloon is, but at the same time, you might have noticed that this demonstration is done, and I want to go home. So, look, a bird. All right, so, as you can see over here, this water has gone from solid to an entirely, or to be from its solid to its liquid state, from ice to water, and now you can see that it is undergoing vaporization. These little bubbles here, some people in the other classes called it, that said that those bubbles were air bubbles. Some people said they were carbon dioxide bubbles. They are neither. What are those bubbles made of? Now let's go look at our data. This is our data. I do not feel like doing a screencast on this computer, so I'm just going to hold my phone up to it. Well, you can see that we've observed the two phase changes here from two areas where the temperature leveled out. It wasn't actually getting any colder, the thermometer was just reading it. It takes time for it to read. But after it acclimated, it stayed around here, right around 0 to a few degrees below 0. And then after that, the phase change finished, the temperature began to climb. It was all in its liquid state. It continued to climb, until it got to around 100 degrees, where it entered its second phase change and began to turn into a gas. The reason that this doesn't continue, up after this, is actually due to the limitations of our thermometer. This thermometer is really bad at detecting water vapor. We can see with our eyes the water vapor coming up. You can see the little bits of vapor if you look closely. All right? We can see it. This thermometer, it's not good at taking the temperature of water vapor. And so in fact, when you have a thermometer in boiling water, this thermometer in boiling water, what it's actually taking the temperature of is the still liquid water. And if it's still a liquid, it hasn't undergone the phase change, or it hasn't finished the phase change yet. If it hasn't finished the phase change, it can't be a gas. And it can't, and therefore can't exceed 100 degrees Celsius. So that's the actual reason that our graph peaks out here at 100 degrees. Not because the phase change never finished. It is. It's finishing for some molecules right there. It's also important to know that the phase change isn't something that happens all at once. If you have an ice cube and you set it out on your table, it doesn't wait, and then snap of your fingers all at once, it all becomes melted. No, little bits melt at a time. Well, little bits boil at a time too. So parts of this mass of water, some molecules have already finished the phase change, turned into vapor, and risen out of the beaker. What you see here as the liquid are the bits that haven't. All right, so compare what we see on this graph. Compare what you see on this graph here. Pause the video right here and look. Was your prediction correct? If you predicted that you would see all 3 states of matter reflected on the graph, then that's not what happened because of our wimpy thermometer. So just acknowledge that. That doesn't mean that you're a bad scientist. It means I didn't tell you that, which was intentional. Okay? So make sure you reflect on this data and reflect on how it was different from your prediction.